Okay, this is the M1 paper from June 2023. It's question number 8, and as you can see, this is quite a long question, lots of information on it. You might want to pause the video at this stage and just read through the question, or you might want to check the link in the description where you've got the paper there. What you can see is that I've already put a set of axes on here for this vectors question. It tells me that all position vectors are given relative to O, so I'm going to call that the origin there, which for example means that later on C is going to be 25, 25 there. It's halfway and halfway of 50 and 50. And as I say, this is a vector equation question. So let's just really quickly remind you how we do those. For vector equations, we say that R is equal to R0 plus VT. Well, where does all that come from? R0 will generally be where my object, this is a robot in this case, where my object starts off. So R0 is the initial position from it. And then in most standard questions, they'll tell me the velocity or the direction of travel for the robot. And then what I'm trying to do is I'm trying to work out where is this robot's at various different times, where will it be? It's always relative to the origin. So there's R, or there's R, or there is R. That's this one here. And how do I get to those ones? I always think about it as get onto the line first of all using R0, and then move up the line V, up the line 2V, up the line 3V. Well, that's where my T comes in. How many lots of V am I adding on to that? Okay, that's a very quick bit of revision for what's actually going to be going on with our question here. So we have that this small robot starts off at minus 2i plus j. Okay, this is not to scale at all, but it's just to give myself like a little bit of an idea of what's going on here. So it's there at minus 2i plus j. And then a little bit later on, it's over here at 9i plus 23j. This is not to scale at all, but this is just to give me an idea for when I'm going to be doing my first part then. Part A, so I'm going to be using R equals R0 plus VT. What have we got for part A? Actually slightly unusual. We've got R0, that's standard, minus 2i plus j, but actually it tells me that t is equal to 11, and it tells me where it is. It tells me R11 if you want. It tells me R11, but it's telling me where R is at 9i plus 23j, and what it hasn't told me is v, so that's what I've got to work out. So if I put that information in then, so I've got that 9i plus 23j, that's where it's ended up. It started off at minus 2i plus j, and we had 11 lots of the velocity to work that out. Okay, so this is just a equation now. 11v works out to be equal to 11i plus 22j. Well, they're nice numbers, aren't they? Because that then means that v is going to be equal to I plus 2j. And what they want r now. They want r in terms of i's, j's, and t's. So if r is equal to R0 plus VT, then r is equal to the minus 2i plus j where we started off from, but then the velocity is I plus 2j multiplied by t each time. That's okay to have as the answer, but realistically for what we're going to do later on, it's better have it in terms of just i's and j's. So I'm just going to tidy that up a little bit in terms of saying that's ti and 2tj. So what I can now do is I can write it down as how many i's and how many j's. It's, what have we got here? T minus 2, lots of I, and then 2t plus 1, or 1 plus 2t, doesn't matter, 2t plus 1, lots of j. So I'm going to leave my answer like that because I know that's a little bit easier to work with later on in the question. Part B, what does it say? So we've got a second robot, S, which is at the point C. Yes, I've said that already. C, it's starting off here, and it's actually moving with minus I minus j. This one would be moving in that direction there. And it says, can we write down an expression? It doesn't use R this time, it uses S, but that's fine. Can we find out what S is going to be then? Yeah, absolutely we can. So using the same thing, I'll start off with R's to start off with. R equals R0 plus VT again, but here, R I'm going to call S this time. If it starts off at C, that's the point 25, so it's the position vector, 25I plus 25J. We do know velocity this time is minus I minus J, and T, well, we're going to have it in terms of T. So plugging all that information in, we will get S is equal to R0, which was 25I plus 25J, plus VT, so plus minus I minus J, lots of T here. Tidy this up, that's going to be, oh, right, okay, it's going to be 25 minus TI, I'm going to do it quickly, and it's going to be 25 minus TJ there. So that's where my S is. And then it says, sorry, part C, can we show that SR is given by something? Okay, let's just remind ourselves how we do this with vectors. If you have a point A with position vector A and a point B with position vector B, I've told my students, and you should get this, that's just going to be B minus A. Every single time you can go, wait, sorry, a little B there. You can work it out by saying, oh, right, if I want to go from A, B, it's down there and up there, but learn that. That's going to be really useful to us as a quick shortcut when we're looking at things in 3D. PQ is Q minus P, AB is B minus A. So in this case, SR straight away is going to be R minus S. So that's going to save me a little bit of time here then. So that's going to be R, which was, what was it, T minus 2, lots of I, and 2T plus 1 J minus the one that we can see here, 25 minus T I minus 25 minus T J. Be careful of it. When I'm minusing this thing here, there'll be a minus there and a minus there, won't it, when I'm doing it? Let's get rid of that, my previous answer though. So, yeah, tidying that all up is then going to give me what we just had, 2T minus 27 I plus 3T minus 24 J, which was what they asked for in that first part there. Okay, this part D is a standard that we'll get for this type of question. Can we work out the minimum distance if they don't actually meet, which these ones don't then? I always do these in the same way. There's lots of different ways that you can do it, but I'm going to stick with the way that I always do it. If I've got SR there, so SR, what I'm going to do is I'm just going to say go away and check in the answer scheme if you want the examiner's report. It'll give you other ways if you're more comfortable with another way, then do it. But I'm going to stick with the way that I always do these, which is to say, right, so the distance is just the modulus of SR here, which is going to be the square root of 2T minus 27 squared plus 3T minus 24 squared. So if that's true, then D squared will be getting rid of that square root. So 2T minus 27 squared plus 3T minus 24 squared. And then all I do is I say if I want a minimum of anything, I just differentiate and put equal to naught. So let's just say that the modulus of SR now is going to be, not the modulus of SR anymore, D squared, sorry. D squared is going to be, multiply that all out. So multiplying out 2T minus 27, perhaps part of the reason I do this is because I can do that really quickly. I know A minus B all squared, but you take your time if you need to. But I'm going to do it quickly here in terms of the sake of the video. That bit works out to be that. This bit works out to be 9T squared minus 144T plus 576. And so that then tidies up to 13t squared, 252t, and a constant there. So for the maximum or minimum in this case, the differential is equal to naught. So the differential of 13t squared minus 252t is going to be 26t minus 252. That's equal to naught, which gives me that t works out to be equal to whatever that is, 126 over 13, or 9.7 seconds. Let's just go back and make sure I've answered the question. Yeah, find the time when the distance is a minimum. If it had been to actually find the minimum, I'd have had to put that back in. But no, just find the time when that happens. And it is in terms of seconds here. We're just checking that it wasn't sometimes with these questions, they'll say it starts off at midday and you've got to add on a certain number of hours or whatever. So that's the answer to part 8 there. Really good question to just review a number of times because there's lots of standard things in there that we need to be aware of. Hopefully that all makes sense to you guys.